Welcome everyone to the NGSS Assessment Academy Part 6. Today we're going to be talking about building NGSS assessment systems with backward design. My name is Brendan Finch. I was a high school and middle school science teacher in Los Angeles. I taught for LAUSD, KIP, Green Dot, which is a charter network, so is KIP in Los Angeles, and then Kava, which is a virtual charter school. And I'm really excited to share what we've learned today with y'all. I'm grateful that you're here and spending time with us. We are here because we've now written thousands of phenomena-driven NGSS assessments for grades 5 through 12 on inner orbit. We do offer free pilots. We find eye-catching phenomena and we build those into diagnostic, formative, and summative assessments. Today, we're going to talk about backwards design. We're going to start out with why UbD and the NGSS. We're going to talk about sense-making summatives. We're going to go through a high school example for HSLS42 and a 5th grade example for 5PS11. We'll break down some standards and we'll go through a 2-dimensional formative or a couple of those examples. And then we'll talk about scaffolding up with diagnostics, worm-ups, and exit slips. Really, this is just a place for anything that we wouldn't consider a large formative assessment, but is still helping to inform instruction and check for understanding or what have you. And then lastly, maybe you'll let us plan a unit of your assessments. We'd love to do that. Why UbD and the NGSS? I don't know. Well, transfer and application is the answer. Both of these start with an end in mind. UbD is all about understanding by design. It's all about starting with the end. The NGSS is also all about that. So performance expectations are what we want students to be doing at the end of a grade level band. Both of these want students to be transferring knowledge and applying knowledge. These are core tenets of both of these, systems. For NGSS, we want students to be able to look at a new phenomena and make sense of what's going on. We want them to apply what they learned previously and explain what they're seeing now. The end goal of both these is an enduring understanding. So let's talk about sense-making summatives first. I talk about this at every single session because it is the most important thing. When you're building a summative assessment, having a phenomena is very important, but the phenomena needs to be used for sense-making. So attributes of a good phenomena are, it needs to be specific, it should be novel, it should be non-obvious, so the answer is not very obvious. And also you need the phenomena prompt in order to answer the questions. So a bad phenomena is, here's a boiling pot of water. A good phenomena is, here are these lanterns and they're floating up in the air with a flame, some fuel burning in the center. Why is this happening? Both of these involve average kinetic energy. There's some kind of change that's occurring in the particles, but one is something that students have probably seen before and have represented in other ways. And the other is something students have not seen before. We have an entire session on sense making and phenomena. I strongly recommend, if you have not gone through that you watch that. There is much more to be said on this topic. We're going to start with HSLS42 and we're going to dive straight into a summative because we're starting with the end in mind, and then we're going to move backwards from there to where students will begin. HSLS42 is a beast. Students need to construct an explanation that talks about evolution being driven by species can increase in number, inherit things due to mutation and sexual reproduction. There's competition and organisms that are better able to survive and reproduce, proliferate. And that's that. This is an absolute beast of a PE. But we have assessments for this. Why are there so many species of sportive lemurs is the phenomena that we're going to be looking at. This actually comes from a research study on sportive lemurs in Madagascar. And in Madagascar, it's really interesting. There are all of these different sportive lemurs, incredibly diverse. And as you go around the island, they are all over the place and they are very different. In this performance expectation, it asks students to use evidence from peer review, investigations, models, theories, and simulations. So we are actually pulling this from a true research study that we want students to make sense of and pull apart. Cool. So I'm going to give a couple examples of questions that I would ask as a summative for this. And the first couple questions are going to be multiple choice, and then we're going to top it off with a free response question that's going to pull the room together. A classmate claims a higher rate of survival for one specific trait also leads to greater genetic diversity in a population of lemurs. We're going to ask a couple questions about this claim, and then we'll have a couple questions that don't include all the text of the question because You don't need all of that, but instead we'll outline the flow of questioning that we're looking for. So which statement correctly evaluates their claim, giving students options, having them choose one that correctly evaluates this claim, what piece of evidence supports this claim. Both of these are the type of questions that we see on statewide tests, where students are not doing a whole lot of composing of responses, but they're choosing evidence or evaluations for a claim that appropriately apply all the concepts that we're looking for. Beyond that, we want students to say, how did competition create diverse lemurs? And this can be a multiple choice question as well, with a couple of different claims or statements that show, why competition specifically, because that's one of the elements we're looking for them to demonstrate, creates diverse lemurs. Now that we've sort of scaffolded up and have students evaluate claims, we've had them choose evidence. Now we want them to write a CER statement to answer this question. How can evolution explain the differences in lemur populations? You may create bullet points for each of those elements you're looking for students to hit in the performance expectation, or you can see what comes out in this. I think it really kind of depends on how focused you are on meeting the exact words of the PE, but the general idea is that students understand there are various mechanisms that work together in order for evolution to take place and natural selection to happen. And that's what creates the diversity in lemur populations. So this is a high school summative example. I don't think that you need more questions than this. Obviously, you could accordion this out and have lots more questions around this. But most of the districts and teachers we're working with have bundles of PEs that are together. 2 to 4 is an appropriate number. Let's go into 5th grade. So this is a 5 PS11. We're going to start with this summative. And instead of going into both the high school and the 5th grade examples, we're going to really double down on this 5th grade example. So this 5th grade physical science PE is on develop a model to describe that matter is made of particles too small to be seen. So in 5th grade, we have these really, really highly conceptual things. In middle school, we get into the relationships between all of these concepts. And in high school, typically there's a quantitative element. For the 5th grade, we really want students to be using a model to describe phenomena. We want them to talk about structure and properties of matter, that it can be subdivided into things that are really small. And we need to talk about that there's different scales. Why does cutting onions make us cry? So it's okay, Dawson. The idea is that you come home while your sister is cutting onions in the kitchen, standing there talking to her without touching the onions, you start to cry. The 2 questions we're going to ask students for a summative for this is draw a model to explain why particles from the onions make you cry, and explain how your model shows that matter is made from particles that are too small to be seen. So if students draw this model properly, they will definitely be showing that there are different scales. So they should show that there's an onion and that there's a smaller scale that we cannot see. So they'll be hitting that cross-cutting concept. They're definitely talking about the fact that matter can be subdivided into particles that are too small to be seen. That was another element in the DCI. And then for the SEP, we want students to use a model to explain a phenomena. And this is a phenomena. Why does cutting onions make us cry? Just to be clear, all of these things are things that are on our site. And if you go on the site right now, you can find both of these phenomena and all these questions, and hope they're helpful. Go check them out. Now we're going to break down the standards. I would argue that for a summative, you do not need to do anything to break down the standards. The evidence statements, the actual performance expectation, the SEP and DCI and cross-cutting concept provide ample resources for you to write a very, very rigorous set of items for a summative. In previous sessions of this NGSS Assessment Academy, we've gone over, so California has an awesome, I think it's awesome. I've heard from others that it's not as awesome, but there's an awesome document that they use for the CAST. They're called the CAST item specifications. And it's something that we'll include in the notes below this YouTube video when we post it on YouTube. But they go through examples of phenomena and evidence that students have met a performance expectation. And most of them are built for multiple choice or simple free response questions, which is great. But breaking down the standards for the summative, for what the NGSS and what UbD are looking for, we're not trying to do that at the beginning. We're trying to start with the integrity of the standards, and then we'll go scaffold from there and break it down a little bit more. Cool. We cannot karate chop a watermelon, or even this one looks like it's already cut and they're trying to karate chop it, still not working. So don't do that. Instead, we're going to chop it up into easily digestible chunks and then feed these to students. I don't want to go too far with this analogy, but it's delicious and it's a watermelon, and we'll talk about it a little bit more. We're going to take these really complex PEs and we're going to break them down into a few different things. So first, we're going to look at essential knowledge. So we're going to pick out concepts that students will need to apply to that, drawing the model of the why an onion makes you cry, and also outline how they will progress. So from simple concepts or large concepts, and break them down into smaller and smaller chunks. We want to figure out how to provide meaningful experiences with all this to make sure that that essential knowledge and those concepts tie together so that they can then make sense of a complex phenomena. Separately, we need to identify skills that students need. Something that I think is missing from a lot of the assessments that we've seen are identifying how students just draw a basic model, draw arrows, label things. A lot of the things that y'all mentioned in the chat are exactly the types of things that we find that students really struggle with. And so we need to scaffold that and then address skill gaps. So in your formative assessments, before students draw a model of the particles in an onion that make you cry, they should have been drawing multiple models. They should have been talking about small particles in many, many different ways. All of the things that y'all mentioned are perfect ways and activities for doing that. I love it. Aaron, actually, who's on the call, has built this UbD NGSS document. And when we send out the recording from this, we'll attach this document in there so that y'all can look at this and use it. It's a work in progress. We'll be going through it over and over and over again and refining it continuously, but this is what it looks like at the end. So what we start with is the performance expectation and whatever phenomena we're going to use, how many questions we want to use for it. And then we're going to break down the essential knowledge and skills. So for that 5 PS11, we're looking at, so essential knowledge is that there are different scales. So objects exist at different scales. There are small particles that make up larger things, and matter has characteristics. Characteristics describe what something is. So these are all really discrete pieces of knowledge students should have before they get up into drawing a model of an onion making you cry. Students need to have drawn a model before. So anything, draw me an image showing something, and that's important. Draw arrows to the model. How does a desk work? What are the parts of a desk? Can you draw that? What are the parts of your laptop in this era, or iPad or iPhone or whatever it is? Give them opportunities to draw a model first, and then have them draw a model showing large and small pieces of matter. So the smell of the onion was something fragrant. Anything where they're showing a large piece of matter and then some way of showing a zoomed in view of the particles within that. This is a really, really abstract thing, even if students understand the concept that there are smaller parts within larger things. Being able to represent that is tough. So show them examples of, that sort of like magnifying glass that sits off to the side where there's a picture of something here, and then there's a cutout that pops out, and it's here what the cells look like inside of that. I think doing a little bit of modeling and examples are fantastic. Showing components and interactions is another great thing. Thank you, Glenn. That's excellent. And then at the very, very end, we want to identify where students might struggle. This will help us not just with our formative assessments, but with the smaller little exit slips and do-nows or warm-ups, checks for understanding that we have throughout. I know that students will struggle with the idea that particles are too small to be seen. It's a really abstract concept. The word characteristics, I think, is pretty important, because as students go into standardized tests, there will be vocab words like characteristics that will be on that test. And if they don't know the definition of that word and how it applies in this context, they're going to have a bad time. We also want them to draw models showing different scales. These are all things I think my students would struggle with when I taught 5th grade. And I imagine that this will be a common thing even for middle schoolers or high schoolers, to be able to represent things at a microscopic scale and at a macroscopic scale at the same time. And then how will I respond on the bottom right here? This isn't really what we do, but it's what we would think about, and from those of us that were in the classroom, it's where we would go. So how would you smell different foods? Look, you already talked about it. For the understanding characteristics, I used to use Frayer models or 4-square graphic organizers and give students the ability to write a definition in their own words, use it in a sentence, give examples of it. And there are lots of different versions of these 4 squares, but that worked really, really well for me when I was teaching middle school in 5th grade, to sort of anchor in what this word means and different ways to represent this word. And then I would also say practice drawing models of gases, balloons, anything to show matter that can't be seen, where they're drawing, models to show how that works. And I think that's going to be tough, and it's going to be something that you could prepare students for easily. Give them maybe 5 different examples of drawing models before they get to that summative assessment. So let's look at a 2D formative assessment, and I'll give you a couple questions that I think would be great in here. We want to assess progress towards the performance expectation in this. We're going to look at essential skills and essential knowledge. They're probably going to be bundled together for many of these different elements. They should be higher complexity than the mitochondria is the blank of the cell, but we want to lean more towards representation than sense making. And what I mean by that is that very, very first example we had of a boiling pot of water and those lanterns that were floating up in the air. So the boiling pot of water is truly just a representation. If students were to draw what's happening with the molecules inside that pot of water, they're representing something. They're not making sense of a novel phenomena. They're going over something they've already talked about in class, probably already modeled in class to figure that out. For sense making, students would be looking at how the particles inside of that lantern change as the lantern ascends in the air, talking about density, talking about average kinetic energy, pressure, lots and lots of different things happening there. That's sense making. For your formative assessments, I would say you want to lean more towards representation because it'll give you a little bit better data on what students understand. Once you introduce sense making, it's a huge confound. Students might not understand how to do that. The biggest thing that we hear with standardized tests or with our assessments is like, Mr. or Miss, like, you never taught us this. And that's the case for the standardized tests they're taking at the state level, and also for just critical thinking in general. You're not going to be able to teach them everything. They need to, figure it out on their own and use what they learned in the past and apply it to a novel thing. That's just how this goes. So right now, I think students need a lot of support with sense making. So don't follow this advice in the last bullet point. If your students need support, you should be giving them lots of examples and doing think alouds and talking through how you would make sense of a phenomena that you're looking at. And that's why having multiple phenomena embedded throughout your unit is really important. They can be through our assessments, your own assessments, or as instructional tools. But giving students multiple examples of, oh, I'm looking at this thing. What is this? I don't know. There's smaller parts in it. How do they interact? I don't know. Oh, that's weird. There's fire there. What does the fire do? So think alouds are really, really important. I taught a lot of students that lacked a lot of component knowledge from prior grade level bands. And I did a lot of think alouds when we looked at complex word problems and did a lot of scaffolding to make sure that they could get up in there. For 5PS11, I want to give a couple examples of this, and we're going to show part of that little breakdown scaffold on the side. So a classmate crushes down a pencil into dust and says the dust can't be broken down into smaller pieces. And I'm talking about the graphite of the pencil. Draw a model to help explain whether they are correct or incorrect. This would be a great formative assessment before you get up into that onion assessment. We want to have them look at, all right, if you smash the graphite of a pencil down, you cannot physically manipulate that to be any smaller. So we want students to draw a model to explain if that's correct or incorrect. It'd be a good way to scaffold up to that. We also want to have students list 2 characteristics of a pencil, maybe a multiple choice question. Which of these are not a characteristic of a pencil? And your classmate says pencils have these characteristics. These are all multiple choice questions at the bottom and a free response question at the top. But these are all really concrete examples that we want students to show that matter has characteristics to describe what something is. If they see the word characteristic on a question on a test, they are going to struggle with it unless they've had multiple rounds and are using that consistently as they go through and answer your formative assessments. Cool. So those are some examples of that. Now we're going to scaffold up with exit slips. And I use the word exit slips as a way to just describe all the little crumbles that come off of that delicious summative cookie and maybe formative snacks. So we're going to talk a little bit, we're going to break it down even further. So again, starting with that UbD and NGSS, the performance expectation at the very, very top, and then breaking it down into some formative assessments after that. And then finding little pieces that we can assess along the way that can be used to figure out if students are even ready for a formative assessment and if we need to have other learning experiences along the way. One possible exit slip is, your classmate says that diamonds are unbreakable. Does this mean diamonds are made of one thing that cannot be broken apart? So we want to give another example of a really specific phenomena like a diamond, and you could potentially, take your wedding ring out or something and grind it against something. Probably don't do that. And, look at whether diamonds can be broken, and if they can or can't, why is that true? And just because something can't be broken, does that mean it's not made of many small things? This is a good way to talk about this after we talk about the fact that matter is made of small particles. So after they draw their initial diagrams, they've gone through a little bit of this. This would be a good exit slip to talk about. There are small things inside this, but diamonds can't be broken. I know that diamonds can be broken by other diamonds, but just for the point of talking about it might be interesting. So when a piece of ice melts, it doesn't lose any matter. Draw a model to show what happens to the small pieces of matter that make up the solid ice cube. And this is as it turns into liquid. So we want students to be drawing a model showing large and small pieces. This is a great way to ask students to, this is not looking at a phenomena. I realize that a piece of ice melting is kind of a phenomena, but this is leaning more on representation and less on sense making. Kids have seen ice melt. This is not a novel thing for them. And you've probably talked about this in your classroom, and it would be an easy thing to talk about. So this leans toward representation. It's much, much simpler, but they are drawing a model and they are showing larger and smaller pieces. And then finally, I guess this is something I used to do in my classroom, is use Play-Doh to show what the small parts inside of an ice cube would look like if we zoomed way in with a super powerful microscope. So give students some hands-on activities. There are, simulators and things like that online that they can use for that. But if they can find a way to represent those smaller things, and manipulatives are so awesome, that I'd strongly recommend adding that in as a check for understanding or an exit slip or a do now. All of these questions can be placed anywhere into a lesson. They're not meant to be large formative items. They are formative in nature because it's allowing you to reflect on instruction and what students have learned, but they're just meant to be placed, these little questions that have students go over the essential skills and the essential knowledge that's needed for all of that. Awesome. Just to do a quick little review of the UbD process. So we started with our summative, and then we broke it down into a couple different formative assessments. And below that, we had a couple diagnostics, maybe a CFU, the Play-Doh modeling, an exit slip. We have lots of smaller little activities and questions that we can sprinkle along the way to make sure that all of those skills and all of those pieces of knowledge that we outlined at the very, very beginning are covered, and we have data on that, and we can adjust our instruction to make sure that we meet what we're looking to meet. What if we pre-planned your units of assessments? So this is what we do, and we'd love to help you. So we write custom NGSS assessments, and we do PD for schools and districts. We can set you up with a free pilot if you want to try this out. You can sign up for a time to chat. If you're watching this on YouTube later, it'll be in the YouTube description for you to find a time for us to chat. We'd love to help you out. On Inner Orbit, we track all of this data over the course of multiple different school years. We have longitudinal reports that show change over time in a cohort of students for a particular standard, like a DCI. We also track each element within a DCI, SEP, or cross-cutting concept as we go through and students take assessments. So the idea is that you have really, really detailed and discrete data on this to make sure that we have, you can make decisions around curricula, you can make decisions around learning experiences to make sure that your students are not just getting what they need to learn in this grade level band, but in prior grade level bands as well. If you have questions, please send them to brendan@innerorbit.com. Follow us on Twitter as well. We post phenomena and other cool stuff. And let's meet to backwards design your next unit. So if you have something that you're working on, send us some standards. We'd love to go through and talk about that. Have a beautiful rest of your day. Thank you very much for joining us, and we'll see you next time.